So I'm going to dive into this. We talked about confining zombie data, and I'll talk about what that means. And that's just a small part of what the Komprise software does. So one of our mantras is to know first, move smart, take control. And we talk about analyzing, before you go out and do an acquisition of additional storage or do a tech refresh, looking at spending more money on that, or backup or DR or any of that with the primary side. Of course, our recommendation is to analyze your data first and know what you actually have so that you can act accordingly. And this gets into kind of the industry trends here. This is kind of IDC, Gartner type information. But it aligns pretty well with what we see as well, which is data is growing at about every 2 years, 42% year-over-year growth, and about 90% of that is created fairly recently. 80% of most environments is unstructured data, and that gets to the quiz of how much of that unstructured data do you think is typically cold. What we're finding is about 75% of that data is cold data, and we define that as nobody has touched it, or no application has touched it, no reads, no writes for over a year. And it begs the question, why would we keep that in an expensive primary environment? That's the space that Komprise works within for many of our operations. Now, we do have other use cases outside of that I'll talk about, but that's the big one right there, where we have the ability to save companies a ton of money, stretch their IT budget, and help them keep control of their data. So it's about analyzing first, know the data, know what's going on, manage that, take control of it. If you've got any type of cloud initiatives going on, from a cloud perspective, there's a lot of organizations that have some sort of a cloud initiative, but they're finding that's not an easy thing to necessarily do. It takes a certain amount of expertise, and it's not necessarily cheaper. But if we could migrate 75% of your data to the cloud seamlessly without impacting users or applications or rewrites, I would think that would be a pretty easy cloud strategy. So stuff that we're hearing from customers is data growth is exploding, what we were just talking about it, exponential growth on the data, but not particularly matching the budgets. The budgets aren't growing. Personnel, if anything, is shrinking to be able to handle that. And one of the reasons Dave and I left HPE and working with Nimble, and Jim knows full well that I'm pretty fond of the Nimble platform. That doesn't change with our, changing what we're doing for our job. But we've seen this for years now, where organizations are just throwing money into additional storage because the organization has basically a keep forever policy. They are unwilling to throw the data away, predominantly because they don't know what it is. They don't know whether there's value to it. They don't know who owns it. They don't know where it is. And that gets into the cloud as well, with the cloud silos. As organizations do get a cloud strategy, there's oftentimes mixed vendors. There might be AWS and Azure and different buckets from different organizations. They don't know whose it is, where it is, why it is, and the cloud costs are mounting. And they just need more efficiency and cost savings around that. So generally speaking, when customers come to us, it's either one of two things. Either they have a large data migration that they have to handle, which we do very well, or they need to figure out a way to be more efficient and reduce their cost. And what I would say is cost avoidance. That's where the real ROI is. And we'd say, well, stop just endlessly buying the storage and feeding that data, binary black hole. Stop backing up all of that data, even the cold data. If 75% of your data is cold and nobody's touched it, Why are we backing it up every day, every week? Why are we treating it the same as hot active data? And too many places are treating cloud as a cheap storage locker, and it typically isn't either. It's not particularly good storage locker, and it's not particularly cheap if it's not managed well. So we'd say just stop treating all the data the same. Love Gardner's statement there. Our IT industry, it doesn't have a storage problem, it has a data management problem. And that's really the roots of what Komprise is about. We are a data management software as a service company. So we're not selling storage. We're agnostic. We're not selling cloud services. We're agnostic with all of that. We are doing data management, analytics, and data management. So that's actually how we license it. We license the product based upon the amount of data that you want to analyze, and then everything else I talk about today pretty much comes with that. It all starts with the analysis. Helps you buy the storage you actually need. So if you're doing a tech refresh, maybe you find out you don't need 2/3 of the space that you actually have because your hot data isn't what's predominantly in your primary storage. If we could get that out, it allows you to lower that tech refresh footprint. Hopefully, if you're looking at doing a capacity add-on, we could completely cost avoid that. And I'll show you here in a little bit. I've seen a lot of ROIs where we can definitely push that out anywhere from 3 to 5 years with what's on the floor, and reduced cost by actual cost avoidance. And then agility in the cloud. So we have cloud management tool as well that'll show you, but the ability to get the data there seamlessly, and the ability to manage the data once it's in the cloud. And all of this without any vendor lock-in. So we maintain native access everywhere. So when we move or archive data or copy data, we maintain its native access. If it was a PDF file, it still will be. You can see that data using S3 browsers or through your normal file trees if it's on-prem. Even if you take Komprise out of the environment. So we think that's pretty crucial. We're also going to stay out of the hot data path. So we're going to work on all of this completely out of band. We don't want to interfere with your expensive high performance storage. So this is kind of a splash screen of some of our few of our many enterprise customers. Pfizer might ring a bell. It seems to be in the news recently. Western Digital isn't on this list. That's a customer of Dave and I that just increased their licensing dramatically. So they're leveraging more, and there's many more customers like that. We have use case studies with. And then again, the alliance partners, pretty much with everybody that is anybody, pretty much all of the cloud providers, AWS, Azure, Wasabi, Google Cloud, IBM costs. We are the data migration tool of choice for Pure Storage. Apparently that was just announced for HPE Cumulo. If you're not familiar with Cumulo, it's an independent company of HPE, but they're a HPE complete partner, as are we. So Hewlett Packard can sell Cumulo, they can sell us as well, and they have selected Komprise as the data migration tool of choice, and I'll talk about that a little bit more when we get into the demo, the data migration part. So some good strategic partners and growing. We have a lot of recent announcements with both AWS and Azure. Pacific Bio is one of many of our use case studies. We were able to go in there and identify through the analytics their cold data and helped reduce their costs by about 60% by moving that cold data out of their primary tier and off to a secondary tier. We find when we we look at environments, the ROI is pretty rapid. It'll pay for itself in a few weeks or a few months, depending upon what the cold data rate is and the amount of data that's involved. It's pretty straightforward. So know first the visibility. So we'll do the analysis. There's actually an ROI tool built into it. So you can do some what if scenarios that I'll show you. You can actually see what your data looks like pretty quickly in the analysis. See what would happen if we start doing some plans that would do a move and move data out of the primary environment, and then a built-in cost model that I'll show you that would actually show you what that would look like as far as savings for the organization. Now, the true savings are when we actually hit a cost avoidance event, i.e. saving you from having to buy additional storage or allowing you to buy less in a tech refresh, or at least not expand in a tech refresh. And then we can also do some deep analytics, doing searching and tagging across NAS clouds, multiple cloud vendors, pulling together data lakes for, maybe you want to do some AI against this data or machine learning against this data. We can help with pulling that all together into a data lake. So, and then moving it. So we have a patented, trademarked term of transparent move technology, TMT. It allows us to move the data out of the primary environment seamlessly. So we don't require any software to be loaded to the file system, of whatever the file appliance is. There's no agents. We don't use traditional stubs. They tend to be static and corruptible and problematic. That's kind of an old school way to do it. We're now using native constructs of symbolic links that we maintain as dynamic. They can be backed up, but the backup engine won't follow them. But basically, we can maintain these. So if it was a PDF file, we'll move it natively. It'll be a PDF file even if it's in an S3 object store, and the end users could still see the file if they want. And I'll show you that real quickly. I'm going to break out of here and I'll do a quick spot check and see if I've got everyone there, or am I talking to myself? Everyone out there still?
Yes, sir, I'm here.
Good. I see Victor joined us as well. Thank you, Victor. So this is a file explorer on my computer, and you can see these top areas here. These are normal unarchived files that are local. I'll point out this one on symbolic links. It's about 2000K, just under 2000K. These down here have been archived out. They've been, the payload's been moved, so we have reduced the size, and we replaced it with a symlink. So if an end user or an application goes to look at this file, so first of all, understand by policy, we've defined that nobody's looked at these for a year. You define the policy, 6 months, a year, 2 years, whatever it is. We've all agreed nobody's looked at this, so odds are they're not going to. But if they do, and they double click on that file, it will come up in a read-only format, and they'll have access to it. We can talk more about recall policies and all that in the Q&A, but basically if they decide they want to make an edit on this, they'll do a save as, which will give you a version, and it'll drop back into the policy. If they're just reading it, it's going to cache it. The whole document is there, so they have access to that. Transparently, go back to the right place here. Transparently, so that means you don't have to do any rewrites of any applications. You don't have to do any retrains of any users. Their file tree looks the same. We're just pulling the bulk of the cold data out and leaving that symlink behind. The secret sauce to that is in the properties here. This is our intellectual property. We call it a comprise access address, which basically is the path to where the payload is been moved, and we maintain all the ACLs and the permissions and the file directory structure as we do all of that when we move it over. Like I said, it's going to stay in its native format wherever the target is. So any questions there? I want to pop back into the presentation.
Yeah, Tom, you mentioned that you're maintaining the permissions on the file. Is there any kind of limitations as to the complexity of the permissions that can be stored? Is there any file system compatibility issues between Refus or NTFS, anything like that?
Not that I'm aware of, but individually we check if you had any concerns with our engineering. We're pretty much tied to protocol more than we are platform. So most of what we see is NetApp or Isilon or Windows file systems, and we work pretty seamless with all of those. I don't know of any real sore spots. We do have to watch for platforms that don't support A-time, because we do a lot of our work based on A-time, which is access time. We can also work with modified time, and pretty much everything tracks that. So for example, NetApp on the SMB side doesn't deal with symbolic links directly. We use F policy, so we tap into their F policy capabilities to handle all of that, but pretty seamless through all of them. Does that help?
Thank you.
Sure. So one of our other use cases is data migration. So a lot of times this is where companies will first engage with us. They've got to move a petabyte from one platform to another because they're doing a tech refresh and changed manufacturers. They need to move it from one office to another, something of that nature. We can do that NAS to NAS, NAS to cloud, object to cloud. And for NFS data, we'll do it about 25 to 27 times faster than a typical rsync or a robocopy. For SMB, it's about 7 times faster. And we accomplish that by breaking down the task into components. I'll show you here our architecture with our grid architecture, so we can break that down and parallelize the operation while optimizing the protocol. We'll talk about the grid architecture here in a little bit. It's basically infinitely scalable, so we can put as much work horsepower behind that as needed. Bandwidth becomes the really limiting factor. We can also replicate data, and we talk about replication as like a tertiary DR copy. So maybe you want to have a read-only copy out in the cloud to protect you from some sort of a ransomware event, or maybe from a compliance purposes, you need to have that somewhere else. So Komprise can do that as well. And again, maintaining that native access across all the storage. So even if it goes to an S3 object store, whether that's on-prem, because we can do both on-prem or cloud, whether we do that, you would still be able to access that data with an S3 browser. We don't have to do rehydration to be able to access that data, and that's a differentiator. So some products out there, and they're manufacturer-based products, move the data in 4K blocks, so it can be basically hopscotched in 2 different places, and the only way to get that data back is to actually rehydrate it back in. That can be problematic, particularly if you're doing a bulk rehydration, bulk recovery, and you don't have the space for it, because the whole reason you purchased this was to be able to minimize the amount of footprint for your hot data. We don't have to do that. We can bring files back one by one. We don't actually have to bring them back at all, and I'll show you a little bit about that when we get into the demo. So access anywhere, wherever the data lands is still capable, and no lock-in. We don't, even if we get pulled out of the environment, doesn't matter. This is the big portion of what Dave and I locked into, because we've been doing primary storage for a long time, and it was really, getting more value out of your existing data storage being able to leverage it and recycle it for your hot data. And we look at it if there are some other use cases where it's not about the ROI. Working with one organization, they really want to automate things. So it's less about the ROI than it is taking the workload off of IT. So that's fine. Migration is not necessarily about a cost ROI, but most of the organizations that we're looking at, it's literally about cost avoidance and can we save time and money on this. Now, what's important about this is where Komprise operates is prior to things like antivirus scans, backup operations, DR operations. So when we talk about saving money for primary storage, and that's really the goal, we'd have to take a deep look at why you would do business with us if we're not saving you money. There are use cases, but that's one of the big ones. If we're not able to do that, we've got to look at it closer. But when we talk about saving, it's across all of that. If you've got a primary copy, you're backing it up every day, you're running antivirus scans on it every day, and you're doing a synchronous or a asynchronous DR copy to an offsite location, the ability to improve all of those operations is huge, because if we're able to pull 50 to 75% of your cold data out of it, that means your backups are going to run 50 to 75% faster. Your antivirus, likewise, you're going to cut down storage in your primary and your secondary DR facility. That's going to simplify everything across the board. So it's a bigger picture than just the primary storage by itself. And that could relate to storage or licensing costs. If your backup is tied to the capacity, either by the number of data movers or whatever that you have deployed sockets, we can actually reduce the cost of your backups as well. So it's kind of a big picture. This is the architecture. We'll drop into the demo here shortly, but I want you to see the architecture. So here on the left side, this is your normal day-to-day data center. You've got your users and your applications interacting with your sources, your primary tier 1 NAS or object storage. We don't interfere with that. We don't need to put any agents or anything out here. What we do is we put a director, typically in our cloud. It's what I'm going to show you here in a little bit. It's the GUI that sets up and manages everything and provides the metadata, graphics, and charts and feedback on it. So that's kind of the management utility. That operates in our cloud, so there's nothing you need to do in your environment. In your environment, we drop in a grid, which consists of at least 2 observers, typically for HA. They are OVAs that go into your hypervised environment. So pretty lightweight OVAs that go in. And then if you've got SMB environment, we'll also put in Windows virtual servers with a proxy service on them. Commonly they're 1-for-1, but they don't have to be. Just depends upon what the mix is. And as I said earlier, this grid can be expanded. So you might start with 2, but if you're doing a big data migration, maybe you expand it to 10 for the data migration, and then you collapse it back down. We don't license by these, so you can deploy as many of these as you want. Likewise, our software is licensed by Data Analyzed. We don't care where it's analyzed. So if you have 2 different sites, we might have 2 different directors, one for each site, and you'll have your observers and proxies for those sites, but that license is across all of the sites. And then the observers and the proxies, they're doing all of the heavy lifting. So they take the instructions and the scheduling of what to look for the plans. They do the analysis, and then they execute those plans. So if they're going to do moves or copies, they'll push it out to the targets, whether that's an on-prem target or whether it's a cloud target. And quite frankly, it could be either. Different plans might do different things, so you can push that out over there. So that's just kind of the brief view of the architecture. Pretty straightforward. We set up the director for you. It only takes me a few minutes. Oops, sorry, I bumped my mouse and now I'm all over the place. We set up the director, the observers and the proxies are downloaded from the director. Most environments can get set up in just a couple of hours. The biggest slowdown is just getting IP addresses, network security, things like that through. So it depends on how streamlined your organization is. But the actual operation is only an hour or two to set up. It's pretty quick. I'll pause right there and say, you got any questions so far?
So an hour to two to set up. What's our ongoing commitment as far as care and feeding?
Great question. I'm gonna find my right thing. If it's done right, it should be almost nothing. Sorry, trying to get rid of this one. There we go. It's a deterministic approach, so it's pretty much set and forget. Now, realistically, you might be looking at this 30 minutes a week or something like that just to verify everything is doing what you want it to do, checking for alerts, but it's going to alert you. It's going to send out alerts if there's a problem. And our support might contact you. But unless you're making changes to your plans, it's a deterministic type of an approach to where you set your plans, your SLAs, and it takes care of itself. So there should be almost nothing after the fact.
What about tagging? You said you could do tagging to be able to identify like applications and that type of stuff.
Correct.
I'm assuming it's not going to be able to just read it's this application. You're going to have to go in and create it and then tag it to folders, I'm assuming. Then anything in that folder gets tagged with that data.
Through deep analytics, we can do, so I'm running a little bit out of my normal pattern here. So through deep analytics, we can query and find all sorts of different data. So we can read your tags if you have applications that are tagging, or we can come through and run a query and say, we want, this is all demo data, so I don't know what I'm going to find in here. So let's see if I get anything. So we can add in a type and run a query on it. And yeah, I got nothing there. So once we pull up data, I'll do it by file type. Let's say, VM files. We run it in, we pull this up. We can come up here and we can apply tags to it and tagging tasks. And then we can come back and run queries and we can actually search on those tags. So whether that is a tag that you've applied through your application or through ours, and then you can rerun queries based upon that tag and pull up the information on that, whatever falls into that category. So you can see here, over 3 years old, project, tag is a project. And then we can graph all of that. So we can see, well, what's the top shares, top file servers, top owners, top groups, extensions, file types, and you'll notice it shows the age. Of course, our query was looking for anything over 3 years, so that's what's going to fall out through all of this. But we can dig down through and look at different file types. One of the ones that I typically show is rich media. So if I want to search for all the rich media, I can come through, pull to presentation audio, yep, run that, and we can pull out a query there across all of the data. So I have to redo that filter because I did it out of order. So I'll do it real quick again. So this is one of the features that was added in the last year is deep analytics. So once we've crawled the file system, we have the metadata on all of this, so we can use this for doing all sorts of various search criteria, tagging, reporting. For example, I can pull up the top 1,000 files. We can outload download a detailed CSV on all of this, so you could do scripts and operations, if there's something that you need to do with this. Now, I'm told by the end of Q2 of this year, our Q2, we'll actually be applying this ability to operate plans for archive copies, things like that. So we don't do that today, but we will. That's probably the top of the roadmap plan, is to do actionable deep analytics, and we have a lot of customer demand for that. Does that help?
Yes, some. Still, if they don't tag it with metadata, it seems like there'd be a lot of manual tagging that would need to be done. And I'm pretty sure that's probably what's going to happen with our data.
Yeah, it depends on what it is, but yeah, we can, pull information through deep analytics through a lot of different other queries. So it kind of depends on what you're looking for as how manual that's going to be.
Yeah. Now, say you start archiving all of your data to Cloud Provider 1. I guess things change and they want to move everything off of that onto Cloud Provider 2. Is that all just automated saying, hey, move all our archive data over? Simple within Komprise, or do you have to actually do a whole migration?
You'd have to do a cloud migration from the one to the other. And I'll show you that. That's another tool out here called CDM. It's actually part of the greater tool. It's just a different director. But if I can get you to hold that thought, I'll actually show that. Okay.
All right.
So, I'm going to start with the dashboard here. Just kind of a quick overview of the director. But one of the first things that we would go into is the shares, and we'd identify the file server shares that we want to see as sources. So it's a simple operation of adding in the platform and credentials of sorts to be able to access that. We would then do the same for targets. We can have cloud targets that we can add in, or we can do on-prem targets. There's kind of a mixed bag for a lot of reasons. Some customers will use on-prem targets. So we can add in whatever we have available to us, and we have that pool here. And then once we've added in these sources, and I'll show you here, this one doesn't have any shares enabled yet. We can come in here and we can enable the share. That enabling of the share starts the data crawl, and we'll go through and do the analysis of everything in there. And you can see here it's starting that operation. We thump our chest a little bit and say, we do maybe a petabyte a day of analytics. So we can do this very rapidly, and we'll start putting up estimates almost immediately. So you can see this is doing an analytics right here on that one that I just added. We've had some others, but it'll start putting up this dynamic donut pretty rapidly, giving us a nice overview, and then as it goes through that analytics, it'll tighten it up. But we can see here in this demo, we've got 6.3 petabytes. And at a glance, we can see what's hot. We can see as it cools off in the blues. This is cold data now, hasn't been accessed for 1 to 2 years. This hasn't been accessed for 2 to 3 years. This is over 3 years. This is the default coloring that we have as far as that bands. There's some changes that you can do to that. And we also are able to project your growth curve. So we can see what the growth trajectory will be. And you can see here in the next 3 years, it's going to go from 6 petabytes to 11 petabytes. If we just look at the 1 year mark, we can see it's about a 20.5% year-over-year growth on this. Pretty typical that what we see, although I've run into some organizations that are much faster than that. And a lot of this is for IoT type machine created data. So we see this a lot with biosciences, a lot with medical industry. There's a lot of machine generated information, not your typical user directories and things like that. So this gives us a trajectory here. We can go in and now look at our cost model. So we start out with some default numbers, and I'm going to edit these a little bit. So depending upon what your cost model is, like if you're going to Wasabi, they're like $72 per terabyte per year. They might have very little onboarding cost. Maybe your primary storage is $600 per year. Maybe your backup is $200. Maybe your backup software doesn't really apply a lot, but we can edit these numbers in here, and it'll total up what it costs to keep storage on-prem in your primary versus move that to an offsite, that delta, and this is the delta cost right down here. So that's what's feeding into the cost model. So we can start with some IDC averages and things like that, but we kind of encourage you to stick your own numbers in there because it'll be more impactful. And then once we've updated that, we can come over here and start looking at plans. So by default, it's going to build out a particular plan, and then you're going to set up groups. And groups are just, think of them as collections for SLAs. So the group is really a share or a group of shares that are going to have the same type of an SLA. So we can open these up. We can see which ones we want to add in to that share or to that group that we're going to apply a very similar plan to or SLA. And it won't allow you to mix. So a share can only be in one plan at a time. We don't want to kind of cross the streams, as it were. So we can add that in, and now we can make different ones. So we can categorize out. Maybe it's PACS images, maybe it's financial. It could be department, it could be project. Whatever makes sense for your organization, you set up the groups, name them into something that makes sense for you. This is just something that was left over from my last demo. And then you can start applying a plan to it. And we really work this from the bottom up. So the first thing that we can do is say, if a file is more than 2 years old in this particular SLA, we want to confine that. So we'll do this first, and we'll actually move that to a hidden folder called Komprise Trash on the primary storage. We don't actually delete any data ourselves, but this is tantamount to a recycle bin. So this is placing it in there so that your administrators, you can do a script, a cron job or whatever to delete that, or they can go in and manually delete that. So you can actually start the process of pruning data out of the environment. Then we could do a copy operation. Let's say whatever we do here, we want to copy this between now and 2 years, or now and 1 year. We want to make a copy of that. That'll actually push it out, and we can set where do we want to make that copy to. Maybe it's an on-prem tier, maybe it's a cloud tier, whatever we want to do there. And then finally, we can get into the archive part. We can say, well, if nobody has touched this data in a year, we actually want to move that out. We can set the tier that we want it to go to, again, on-prem or cloud. And this will do a transparent move. It will leave the symbolic link behind and then move the payload. It's actually, it does the copy of the data, does the checksums, make sure the data integrity is intact, sets the permissions, the securities, all of that. Then it comes back and deletes the data on the primary source and replaces it with a symbolic link so that it's all attached together. But you can see as we do that, we start building this hashed area. This is what's going to move off. And just that one alone is going to move off 1.4 petabytes of data, 22% worth of data. And we can start seeing our cost model indicate what's going on there. So now we can go through some of the other ones and we can do similar. Maybe the remote offices is a little bit more aggressive. Maybe the capacity is a little less aggressive. Whatever we want to do on here, we can set this up, and we can see in a what if. So we've not actually caused anything to happen yet, but we're doing a what if, and we can see, well, with this plan, if we were to execute this plan, we'd be moving off 4 petabytes, almost 65% of the data space that would be saved. And based upon the cost model that we plugged in, this is the potential cost savings that we can do if we can do an avoidance of some sort of a cost threshold of buying new storage or tech refresh or anything like that. So this is why we would say before you go buy any more storage, let's do the analysis, see what you actually need before you do a tech refresh, particularly if you're looking at doing a tech refresh into a higher performance, maybe a more expensive storage platform. Maybe you don't need to buy nearly as much for your actual hot data. And this is the actual cost avoidance. Once we've got that set and we say, well, this is the plan I want to do, we can come over here and we can actually activate the plan. And there's some options. We can activate it, have it generate a file list, or we can just do a test plan and generate the file list so we can look at that information. I'm just going to close that out. And now we can come over here and see pretty easily that we've got this plan looking here. We're going to move over 50% of the data. We can look deeper into this and see how does this look by space consumed by file type, and how's that plan going to act on it, by file size, by the top owners, so we can see who the data hogs are if we want. Some companies refer to this as they use it as chargeback, or they use it as shameback and say, why are you individual, or why is this department consuming so much data? But they can also use it as forecasting and how, where they need to apply the resources, or potentially do chargeback. So top groups, top directories, top shares. So quite a few different profiles there, and we can change this. We can look at specific shares. We can look at shares in plan or not. We can look at specific groups. We can look at by space, or we can look at by number of files. We can generate reports across this, and it'll spit out a CVS report for that. Likewise here, we can generate reports. One of them might be an executive summary report that can be generated out. So neat little reports to have. And then what I like to show is really, I think, a huge part of the goal is to change this trajectory. We first looked at this, and our growth rate was looking at 3 years is going to put us at 11 petabytes. With this plan that I put in place, we've changed the trajectory to where in 3 years, we'll actually be using half as much storage as what we have today. So we've completely altered the trajectory of the growth. There's still growth, but this is now happening in the in the secondary tier, not in the primary tier, which is, based upon our cost model, it's going to be substantially less expensive, as much as 10 times less expensive potentially. So there's a significant cost savings that can be done there. I'll take a breath and ask if you've got any questions at this point.
Yeah, Tom, one thing came to mind while you were talking about this is, we've identified a file system. It's quiet, it's cold, we want to move it off. All of a sudden, business needs change, or departments change, whatever. That data now becomes something that's accessed more frequently. Is there any kind of reporting or alerting or automation that would say, hey, this stuff's really being hit hard now, we need to pull this out of our S3 bucket and stick it back on-prem?
So great question. So yes, if we look at the system and the settings, we can look at our recall policy. So by default, the recall policy is on, and if the data is accessed more than 5 times in 15 days, it'll rehydrate it and put it back automatically. You can edit this. I've got some customers, they never want it recalled. They don't care how often they look at it. And we've got other customers that want it recalled if it's looked at once. So you can edit this recall policy and it'll handle that. You can also go into shares and you do bulk recalls. So that's more of a manual process, but you can come in and you can pull all of that data back if that's what happens. I think the best
Can you
part
apply
about,
quotas to that or restriction? I'm sorry, Tom. Can you apply a restriction or a quota as to how much data comes back without administrator approval? You know, I'm thinking of a scenario. You've got a 5-pound bag in your data center, and you got 20 pounds worth of stuff in the cloud, and somebody runs a script.
yeah, I would have to check on that. I don't know off the top of my head. I don't see anything here on this, but you can control, well, so this would require an administrator to do it. So that's probably your control setup right there if you're going to do a bulk recall. So a department calls you up and says, hey, we need all that data pulled back locally. That's going to flag you that you need to look at the space, you know, how much of that data is out there to pull that back. From an individual file or folder basis, you can set the recall policy accordingly to manage that under those settings. And
Awesome, thank you.
inversely, you can also set up, I'll show you here, source target sync. So by default, this is typically off, but you can set up source target sync. So let's say you've archived information out there, you've got the symbolic links, and the department says, okay, this stuff has been archived, it's been out there for a year or two, we don't need it anymore, we're going to delete it all. So it would actually do a source target sync. So once you've deleted it, there's a delay that's programmed in, and I'll show you what I mean there. By default, I want to say it's like 30 days when you turn this on, 3 months, so 90 days. There's a delay, and we would say match that to your backup SLA, because if they inadvertently delete it and they come back to you and say, we need that stuff back, then you want to make sure that you can pull back the links from your backup and they'll reconnect with the payload in the target, in the archive target. But if that's not the case, if it was an intentional, we want to eventually clean all of that up in the target as well. And that's what source target sync will do. It'll clean it up on both sides. By default, the transfer interval, we're going to do that analysis every 7 days. You can edit that as well. But again, we've all agreed that nobody's touched this data in a year, so every 7 days is probably fine. You might want to do this analysis less often, but we have some customers that'll do it more often. Likewise, migration iteration intervals are daily, and you can change that as well. And that's kind of the lead in to talk about migrations. So migrations can be set up. This is a separate license, so you can get the migration analytics license independently, but it comes in the full license. So if you need to do a migration from one share to another, I've got a customer doing it from Arizona to San Diego right now. They're pushing some data, or tech refreshes. You can come in and identify what the source is going to be. You can identify what the destination is going to be, and then you give it a name. And when you fire this off, it's going to start the migration. There's some settings you can set here if you want to preserve A time, and if you're going to do the group owner permissions. Once you've started this migration, it's going to kick off and start doing iterations across it. So it's going to do a pass through the whole data set, trying to make that copy. That's of course going to run into errors, open file handles, things like that. It's going to error out. And then the next iteration, we would expect that file won't be open, and we'll catch it and we'll copy that file. So after multiple iterations, we'll end up catching all of the files. Once we get to the point where we've got 100% of the data processed, we can come in here and we can tag this to do its final iteration. I can't show you that here now because they don't sit in that status, but you tag it for a final iteration, and that's when you would take the source offline in preparation for the cutover. It would do its final iteration, which should be pretty rapid because you've done all the heavy lifting already, and then you would finalize that and do your cutover. So we can do that all seamlessly, other than the cutover portion, in parallel, out of band. And again, you can size the grid, you can expand the grid to whatever you need to do. So let's see, I've already showed you the deep analytics side. So let me pop over and say, well, now we've got data in the cloud. So what can we do with that? This is the cloud data management portion of our tool. At some point, probably this year, these directors will merge. They're currently separate, but it's inclusive in the license. It's just part of whatever the analytics licensing is. But most of what we can do on-prem, we can actually do with the cloud buckets. So we create that same data donut, come through the same process. You add in your data stores. You can see quite a few of them here are going to come up. So we add in the data stores. We can enable the buckets, or maybe not that one, but we can enable in whatever we want to look, including across vendors. That starts the data crawl, even though it's in an object S3, and then we can look at the plan on that as well, so we can see what's involved out there, and what the growth plan is going to be. And then we could do some of the same stuff with the plan. Let's say we want to do some archiving with inside Amazon. We can say, well, it's set up to be in standard IA in 3 years. We could change this and say, well, we want that to move in 1 year. We're going to add another policy that says in 2 years, if nobody has touched that, we want to move that to Glacier. In 3 years, we want to move that to Deep Glacier, and we can handle that migration with inside theirs. And here we can see what that plan is going to affect, how it's going to affect our cost projections over time, and what our savings will be. This cost model is based upon the credentials of who's logged in to this particular cloud provider. So again, we can do a lot with inside that environment. And then to get to the other questions, if you decided you needed to move, the same type of a migration task that I just showed you on-prem, we can literally move data, and you can see there's various plans here that are in demo mode. We can literally cause it to move from AWS to Azure, or Azure to AWS, or Wasabi. Wasabi becomes a pretty big topic right now because they're $6 a terabyte with no ingress or egress charges. They're pretty inexpensive as a target. So we can manage all of those, and we can do the data moves. Now that's not to say that there's costs involved with egress charges and put charges if you're pulling data out, but we can handle that data move from one target to another. Does that make sense?
Yes, sir.
Yep.
That's pretty much on the demo. All of that sets up pretty quickly, pretty easily. Again, we go through and do the analysis first. Then you can actually do something with it without us involving the hot data path, and being completely transparent to the users and the apps. And then you can, take control of that, not just to primary storage, but the backup, the DR, all of that. So as much as 80% reduction in backup time, 27% faster migrations, and I think the real kicker is reducing the overall storage costs and backup. That's pretty realistic. So that gets us to the last slide, and just next steps. What else can we do for you? What other information can we provide? What would you like to see?